So today we're talking about permutations and combinations, which you may have talked about in Algebra 1, permutations and combinations. Just to give you an idea of the difference between a permutation and a combination, I have two warm-ups. So first, suppose there are 4 teams in the women's gymnastic finals, Russia, China, US, and Japan. How many different ways can gold, silver, bronze medals be awarded? So you could have Russia wins gold, China wins silver, US wins bronze. You could have Russia, China, then Japan. You could have Russia, Japan, China. You could have Russia, US, China. You could have Russia, Japan, US. You could have Russia, US, Japan. And I think that's all the cases where Russia wins gold medal. But you have other cases where Russia doesn't win a gold medal. So we'll say China, Russia, US. China, US, Russia. China, Russia, Japan. China, US, Japan. China, Japan, US. China, Japan, Russia. And that looks like that's all with China winning gold. You could also do US winning gold, which there's going to be 6 of them. I don't want to have to list them all. And then you could have Japan winning gold. And there's 6 ways that you could have that. So there's 6 for all these. So you have a total of 24 different ways that medals could be awarded. For the next question, it's the ice cream stand at the state fair has 4 toppings. Sprinkles, fudge, Oreos, peanuts. You're ordering 3 topping sundae. How many different sundaes can you get? So you can get sprinkles, fudge, Oreo. Now, if you ordered Oreo, fudge, sprinkle, that's the same as the one before it. Because with toppings on ice cream, it doesn't really matter what order you put the toppings on. It's the same 3 toppings. So this would be the same. What else do we have? Sprinkle, raw, fudge, peanut. Oreo, fudge, peanut.
What's fudge?
Fudge is melted chocolate. And sprinkles, Oreo, peanut. Any others? I think that's all. So you have 4 options. So between these 2 problems, how are they different? Well, in the first problem, the order gave different arrangements, gave different awards in the context. In the second one, the order didn't matter. So it doesn't matter if you do sprinkle, Oreo, fudge versus fudge, Oreo, sprinkle. It's the same thing. The order doesn't really matter. How are they the same? Well, I guess you could say they all have 4 options. A permutation is when the order matters. A combination is when the order doesn't matter. So the first part of class we'll talk about permutations. The last part of class we'll talk about combinations. So a permutation is an arrangement of objects, which could be people, numbers, letters, etc., in a certain order. The order of the object matters. A different order creates a different outcome. So if you had Russia, China, US, that's different than Russia, US, China. A different order gives a different outcome. Number of permutations on n objects taken r at a time. The notation looks like this. NPR, so this is like n would be 4 teams. And you're permutating 3 of them because 3 get awards. Or the book uses this notation, P and then N comma R. The formula is this. So you have N factorial over N minus R factorial. So one like this, we'd have 8 factorial divided by 8 minus 2 factorial, which would be 8 factorial over 6 factorial, which would be 8 times 7, because the 6 factorials divide out. The button on your calculator is right here. 8, math, go over to number 2. 8 permutate 2. So you get 56. 7 permutate 5 would be 7 factorial over 7 minus 5 factorial, which on the calculator would give you 7 over where the factorial button was, but it's number 2. 7 permutate 5. So 25, 20. We have how many 3-letter words are possible in the English language if a letter can be used only once. So in a previous lesson, we could do it this way. You have 3 positions to fill. You have 26 letters in the English alphabet. And you're only using each letter once. So you have 26, and then 25, and then 24. So that's how we did it on the last section. What we can do this time, I guess it's faster, is 26 letters, and you're picking 3 of them for a 3-letter word. The word doesn't have to make sense. So you have 26, permutate 3, which is, there are 15,600 possible 3-letter words in English. That's just possible words. That's counting words like ABC, which isn't really a word in English. But it's also not counting B-O-B, Bob, which is a word, but you reuse the B. So there's at most, I would say, 15,600 words. There's probably fewer than that, though, in English. 8 people enter a best pie contest. How many ways can blue, red, and green ribbons be awarded? You have 8 people. You have 3 awards, and the order matters. Whoever wins first can't win second. So you have 8 permutate 3. And the answer would be 8 permutate 3. 336. 336 ways to award ribbons. And then last one, then I'll let you try a couple. There are 8 people running in a race. How many different outcomes for the race are there? So how many different outcomes? All 8 people are finishing. So you have 8 people, and you're permutating all 8 of them. You could also think of it as 8 factorial. So the formula looks like this, where 0 factorial is defined to be 1. So you get the same answer as 8 factorial. So you could just do 8 factorial, which is 40,320. So how about you try question number 4, 5, and 6, and then we'll talk about a different type of permutation. So there the answer is 4, 5, 6. The next part is dealing with when you have repetition. Repetition. So you have n factorial divided by dividing out the repeats. This often occurs with words, and you want to know how many different ways can you arrange letters in a word, like Jeff, J-E-F-F, but you have 2 F's. So the problem is, if you try to list all the ways that you could write Jeff, these 2, I switched the F's, but you can't tell. The only way you can tell is if you're really strange and you put numbers to show that you switched the F's. People usually don't write their name, especially, even if they're a math teacher. People usually don't write with subscripted numbers. So the way you answer this is you want a 4-letter word. It doesn't have to make sense. So you do 4 factorial is the number of letters. And you have to divide out, that's what this part is, divide out the letters that repeat. So you're going to divide 2 factorial because you have 2 F's. So I'm too lazy to use my calculator, so expanding, you get 12. So there are 12 different words. So one of them would be fefje. Another would be Jeff.
You got talking Russia?
Another one would be
Russia.
Ijif. Ijif. There are 12 of those. How many different 6-letter words can you make out of the word banana? So you have 6 letters, so that's 6 factorial. If all the letters were different, then that would be your answer, 6 factorial. But you have repeating A's and repeating N's. So you divide by 3 factorial, and you divide by 2 factorial. 3 factorial for the 3 A's, and the 2 factorial for the 2 N's. And then you can get the answer for that. See if you could do number 9 for the state in the United States named Mississippi. Okay, last part of class, one more page, page 6. Consider the following. You have 3 people. Person number 1, person number 2, person number 3. The possibilities, here's the difference. We've just been doing permutations where the order matters. All these are different groups, so there would be 6 different orders of 1, 2, and 3. And I gave you all 6 possibilities. Combination, the order doesn't matter. So if you have 1, 2, and 3, and you rearrange them, it doesn't matter. 1, 2, and 3, 3, 2, 1, 1, 3, 2. It's the same group of 3 people. So there's 1 group of 1, 2, 3. There are 6 groups when the order matters. So the last couple examples I have to show you relate to combinations. A combination is an arrangement or selection of objects where the order is not important. The textbook uses this notation. I like to use this notation. You could also see this. You'll probably see this in pre-calculus, where instead of using a C at all, just parentheses are used. But the formula is this. The formula is really similar to a permutation formula. And you'll notice the n and half of the denominator are the same as the permutation formula. All you have to do is divide out the repeating groups. So it's kind of like dividing out repeating letters. You have to divide out repeating groups. So evaluate the expression. This would be 5 factorial divided by 2 factorial, 5 minus 2 factorial. The button on your calculator is right here. 5, go over to math, over to PRB. 5 choose 2 is 10. And 5 choose 3 would be 5 factorial, 3 factorial, 5 minus 3 factorial. And you use the same button on your calculator. 5, hit math, over to PRB, number 3. 5 choose 3 is 10. Now you might think, are we always going to get 10 for 5 choose whatever? Well, you actually don't. 5 choose 1 is 5. 5 choose 4 is 5. So you don't always get 10. But there is a relationship between 5 choose 2 and 5 choose 3. 5 choose 3 is the same as 5 choose 2. Choosing 3 is the same as not choosing the other 2. But let's look at a couple word problems. Pizza shop offers 12 different toppings. How many 3-topping pizzas can be formed with 12 toppings? You have 12. You have 3 toppings. And the order that you put the toppings on the pizza, the order doesn't really matter. If you have pepperoni, sausage, and olive, it's the same as olive, pepperoni, and sausage. Same thing. So you'd have 12 choose 3. And your English teacher asks you to select 3 novels from a list of 10. The order that you pick the 3 novels doesn't matter. Whatever 3 you pick, it's the same if you switch them. Same 3. So it'd be 10 choose 3. So there are those answers. For number 12, see if you can identify if it's a permutation P or a combination C for 1 through 4.